Thanks a lot, Christian, for the great introduction. I think that's a really tough act to follow, I must say. But everybody looks so amazingly energized today, right? It seems like everybody had 1 extra hour of sleep right now, right? Yeah. We should do that every day, right? We should always set our clock a bit fast and do that way. So today, I want to talk to you about RISC-V. And first, a show of hands. How many of you know what RISC-V is? I think that's 99% of the folks here. So I think we won't bother you with a lot of details today, but we'll go into some of the details and see what our partners are actually up to. Last year, at the Ubuntu Summit, we had a great presentation done by John Roncombe from Sci-Fi. They described basically where RISC-V is, how it came to be, and what is the ambition of the whole RISC-V community. But this year, we have a bit of a different presentation. It's not a person who is representing the RISC-V ecosystem from the IP side, but they're actually building devices. And I think that deep computing truly embodies what we came here to set out in the Ubuntu Summit, which is basically giving the stage to people who are willing to challenge the status quo and disrupt. Because as you can imagine, RISC-V is still an emerging ISA. It's a growing ecosystem, but building devices, consumer-grade devices on RISC-V is really not for the faint of heart. And it's truly an amazing endeavor that our partners are doing. Deep computing, they are the pioneers of creating RISC-V consumer devices. And why is this actually so important, right? Because it moves RISC-V from the domain of being run in specific workloads, in microcontrollers where we don't see them. And it brings us closer to the developers where we can touch it, use those devices in familiar form factors, build software on top of it, try to port our projects on top of it, fail porting the projects on top of it, then fixing those problems, contributing back to the open source community. And this is exactly what the RISC-V ecosystem needed. And that's why deep computing was recognized during the RISC-V Summit just a week ago as one of the key contributors in the whole ecosystem. So I would like you all to warmly welcome my friend and partner, Yuning Liang, the founder of DeepComputing.
Hi. Hi, everybody. Hi, thank you, Gordan. So for those who don't know me, I just do a brief introduction. I'm Yuning, founder of DeepComputing, doing some crazy things. So what we do, actually, we make the premium RISC-V product and RISC-V only. So we do consumer electronics, and we do, just now Gordan says we make laptops. So, and loads of other people here on our website, we make some RISC-V power toy cars and balloons. So, and today I'm going to talk about a little bit about RISC-V and what's it all about and how we look forward. So, and RISC-V, the prospects to me is pretty good. It's the big dream. The dream is very big. And you can see one day we reach 30% of the ISA market against the current x86 and ARM, and you won't find other exciting opportunities around it. So among all, you can see it's hard for any other company not talking about RISC-V and doing RISC-V secretly, right? You can see a lot of big players. So we are up against a lot of fun party and partners. So RISC-V journey, is it hard? It is very hard. You set it up in RISC-V International, originally from US, and then they move it to Switzerland 2010. And we look at back, x86 is going through a hard time as well on the PC and server side against anyone we all old enough here to talk about SPARC, HP, Unix, and SGI. But they're really big. It becomes very big from 90s and 2000s, and now still very big. So same as ARM, I used to run Nokia's feature phones platform software. So we all using ARM. The time we use, and the last project I used 1 gigahertz ARMs. They're not calling Cortex yet at the moment. So, but since on Google, Apple take over the ARM and push to mobile, and then Qualcomm, MTK, and start become the dominator. So, what's RISC-V? What it's going to do? Works really on PC, on mobile, on some other consumer electronics, or now everybody talk about large language models on AI, how? And from when? When we can scale up. So from 2020s, so by that time, when I realized, and there's much of the end user product, so I decided to do laptops. So, and then when I started deep computing, this startup, well, I look at the fate of RISC-V and destiny. Is it going to be like Linux, right? It's the past. And what about present? What about futures? What it looks like? So x86 is a very close ISA. If from US, it's driven by US, dominated by US, right? It's a close owned by Intel, now AMD, and recently established advisory groups. So ARM actually is from Europe, right? It's driven by the global. So you can see there's no one dominate specifically from certain regions. It's a semi-closed. ARM owns the ISA, doing the IP, give it to the chipset guy to manufacturing to make the SoC. It's semi-open, semi-closed. And RISC-V is opened up by Berkeley, by David Patterson, good old friend we used to meet. And then to avoid geopolitics, he moved to Europe. And you will find out it's primarily driven by Asia, especially in the chipset side. The IP side, still very strong in the US. So it's very open. It's ISA is very open. People heard about the recent news about ARM telling Qualcomm off, you can't use it, the ISA anymore in 60 days or something. So, but RISC-V is truly open. And what's the problem of RISC-V? Actually, it's a community-driven. It's going to go through the pain slow, very slow, long road, exactly the same as Linux. Be one day it's going to come. So how do we make RISC-V a successful reality fast enough? Right. Here, I'm sure a lot of we are all software guys, including myself. So, and we often talk about chicken and egg. The software guy waiting for the hardware guy waiting for the software. We all body spinning around the cycle. So we need to break these deadlock cycles. So what I do as from when I formed the deep computing, so I don't care whether I sell or not. I had to make the products. So, and then I had to involve all the existing players to make the product. And no matter their chipset is designed for their product. So, first of all, and later on, after finding the problem, market let me, telling me what to do, what's wrong, then I will inspire more people to join the dance, join the RISC-V stage. So you can see, when I make the laptop product, I get the IP guy, talk to the IP guy, talk to the SoC guy, and trying to make it. And it's really hard job. And then by the time then after hardware come in, and then the OS, the Debian was the only one supporting RISC-V on the main branch. So, and then we get involved with application browser doesn't work, and all these things, it's very hard. And partnering guys parties is very challenging because you will see people have different goals. It's a commercial company. Most of us is still startup. It's we're trying to survive. Different goals, misalignment, and the chipset technical things. It's not out for it. For example, whatever the SoC I use, they never think about making it as a laptop SoC. And by the time we decided to do it, put everybody together, it's very resource and constraint and intensive because they never think about it. So I do a way that we bring together different partners and they solve for things once at a time. And we, different stage, different partners. And also we will spinning around the circle, involve different partners. For example, when I do the hardware, and mainly involve the IP guy, Sci-Fi, Imaginations, and then the SoC guy like Star 5. And then I sorted out the whole logistic about making the hardware motherboards. And then by the time I got the hardware, I found the hardware is just a brick without software. So, and we solved out the Ubuntu committed to us saying that you're free to use it, and we give you support whatever we can. I feel grateful. And then by the time I make my own laptop a few times, I'm sick of it, and then I get, a framework to support and give us a very nice and good longevity chassis and vision. So after that, the software, you find that the OS is not good enough, and because it cannot be upgraded, and myself doing all the brickwork, repeating, merging the kernel with the OS distributed image. It's a lot of hard work because kernel is not done, a lot upstream. So then all around all these cycles and parallels is keep improving and improving, trying to help RISC-V scales. And then the first step is from 2024, we got Cindy and Gordan's help saying that we are free to use Ubuntu's image and to a no-go and to help to promote RISC-V since the RISC-V summit in Europe. So, and now all of our product runs Ubuntu from 2304, 2404 to now 2410. So it's without Mark and Cindy Gordan support, it's not going to happen. So, but for a startup, making a laptop, and isn't it very sustainable? I'm tired. I make 2 generations of laptops. It's getting better, but it's because the scale of it, the volume is not big, isn't a good approach to doing it. So yesterday, I'm sure you listened to Frameworks lining talks. It's relining 5 minutes. And if I know framework during the COVID, then I would have done my own laptops. It's so hard, so hard. I'm a software guy. I know nothing about structural, I know nothing mechanical, I know nothing about all these things. So I'm sure everybody knows about framework. Now, let's welcome founder and CEO of Framework to talk about what his vision of Framework, as well as the mission, what he's going to do in the 20 years as a slide mark, set it up for Ubuntu for the last 20 years. So, and let's welcome Linov.
Great to see everyone again. This one's going to be a little less rushed than yesterday's lightning talk. Thanks, Yuning. So I talked a bit yesterday about this idea of ecosystem-based hardware. And one of the core concepts behind this is this idea of network effects, that there's sort of a supply side and a demand side dynamic, that if you have enough people demanding a certain thing and enough people supplying a certain thing, that you get this really healthy basically ecosystem effect where both sides boost the other side. But today, actually, I'll very transparently, we have a 6-digit number of framework laptops out in the world, which is, on the one hand, a pretty big number, but on the other hand, a pretty small number. And so as we think about network effects, there actually is a little bit of a forced bootstrapping phase that has to occur, where either the supply side has to basically force the existence of a new device, or the demand side has to become so large that the supply side has to respond to it. And so being able to partner with Deep Computing, with Yuning, and with the folks at Canonical to be able to do this sort of forced bootstrapping phase to bring RISC-V closer to consumer level maturity actually ends up being pretty important. Realistically, we do need to bootstrap the supply side of enabling the RISC-V ecosystem. And so basically, thinking back to this idea of enabling that type of functionality from a hardware perspective, about 2 years ago, we actually kind of preemptively released a bunch of documentation under open source licenses, a bunch of CAD under open licenses, just dropped it on a GitHub, basically as a fishing expedition to see who would bite. We knew we didn't quite have enough documentation there for anyone to like take it and just build something, or at least that's what we thought, because it turns out that the team at DeepComputing did go and just take it. And basically after a couple of months of our first email exchange, come back with like, hey, here's the schematic, we're ready to go. Why don't you guys review it and give us some feedback? And so actually we're very impressed by how quickly the team at DeepComputing was able to pull together that main board and really, again, kind of blast through that barrier to that forced bootstrapping of sort of the first consumer-ish ready version of a RISC-V electronics product. Obviously, this first go-around, we're very much developer-focused. We look around this room, and I imagine many of you are here today because you would like to be some of the earliest developers picking up that combination of a functioning main board in a pretty usable system and kind of help to drive forward that bootstrapping phase as well. But this is, again, going back to this idea of 20-year vision, this is obviously among the earliest steps to that 20-year vision of getting to RISC-V as that 30% market share ISA, potentially even more than that as we look at how those ecosystem network effects actually result in these beneficial outcomes for users, developers, hardware makers, SoC makers, IP makers. Theoretically, this should be a stronger and healthier ecosystem 20 years from now than what x86 or ARM was ever able to accomplish in the last few decades, just the way the dynamics work out, similarly to the way the dynamics in the Linux space work out. And so again, as hardware makers, we're really excited to be there right at the start to do our part to help enable that ecosystem. And I'll hand it back to Yuning. I think we're going to do some Q&A as well.
Thank you. So, thank you. And you can see why I decided to do framework, because the innovation framework come out. The motherboard can turn it to a desktop. So yesterday, enough to talk about the laptop. Now today we talk about how good is that? You turn the motherboard laptop into a desktop, connect to a monitor and keyboard. Off you go. And when I do my own laptop, I often ask people give me excuses not buying RISC-V, even though they're working on RISC-V because they still need Windows. Right? Now, they have no more excuse. A framework, you can swap to x86, you swap to ARM, you swap to RISC-V. So the whole thing is open and up. Thank you, Nina, for giving the 20 years vision about the whole ecosystem. And one day, if Nina, whatever they sell in 1/3 is in RISC-V, my mission is done today. So we found another problem. When we started doing Ubuntu, we had to massage the SoC provided kernels with the image given by Gordan's team. We had to massage very hard. We remember the first time we merged 2304 with a 5.1 kernel. It's enormous hard work. Trying to get things stable is really hard. So I found one problem is that OS not able to build official image. In the RISC-V summit, I bang on the table telling all the RISC-V chipset, you guys had to do better. And now upstreaming activities is exactly the same as probably 10 years ago Qualcomm and MTK, right? So now the SoC guys are making the same mistake again, not focus on upstreaming because they're hardware guys, they barely survive to trying to mass produce the chip with a mass produce quality, right? So, and then Greg went back in Hong Kong, the Linux conference, and Greg and Ines give me a hint. Go and read back the 15 years ago's advice back to x86 and ARM. So we got to upstream. We tell the SoC people upstream. That's why I showed this in the RISC-V summit and bang on all the RISC-V SoC, help them to do it. Then before they finish tipping out the chip, they had to submit the kernel code. It doesn't matter whether it works or not. If it doesn't work, later on we improve it. And if it does work, then out of the charm, right? So that's the advice from the Linux Foundations. So for 2025, our goal is for deep computing products, including all the frameworks, the RISC-V motherboard, we had to upstream. And all the Ubuntu release will straight away build against the upstream kernels. So feel free to backport it. So, and we partner, a great guy, Alex and Daniel, pushing me so hard and let me understand how upstream is important. And then we have Linux kernel, all the big guys help us to make sure that we are much more efficient to upstream it. And then we work with all my chipset, all my chips I'm going to use, and I will enforce them to upstream. If they don't, I do it. So, and how do I do it? We back to Cindy's team. Email is there. So he's going to help. So he's going to work on the AI PC, the first one to deliver 2604, right? So, and more or less, we get some good guys, cool guys, who is willing to help us to do the upstreaming. So, right? So you can see, I don't know why Google Slides still have buggy, but anyway. So you can see my roadmap. So next year, 2025, even more exciting. Here, remember the lightning talk, people want to see it runs, right? It's painfully slow. It's not going to boot in 2 minutes. So you can look up our booth, it does boot, okay. But and next year, we're very excited, right? We have 64-core build machine coming in, and much better quality than last year. And we have an 8-core. I just got the chip out of the factory. I forgot to bring it in here, otherwise we'll show you. And so I have 40 TOPS of AI we're going to put on whichever product sales. And then I might do one last my own laptop. We partner with Alibaba with a very good chassis and with Apple's AS qualities. So at long last, I'm not going to do any more laptops. Right? It's not my thingy. Really can't do it. I leave it to enough. The logistics, the hardware, oh my God, stress me out. and we do a 12, 16 core. So we are for a 16-inch framework, but we see how good is the chip. I don't know. They haven't given me the test chip yet. So let's see. So, and let's work together with this roadmap, and hopefully, Mark yesterday come up to us and tell Gordan, can we make it to 2604? We will try our hardest to get it into 2404, but I need enormous help from Canonical in terms of the certification, compatibility, a lot of other works. Thank you very much. Thank you. And today is pretty early. See how many minutes left? Yes, we're still on time. And to appreciate you guys here, we are up for some question. And Gordan, you're coming back out? So, and I got a lot of freebies for you guys to up and early. And we take some questions from you guys on RISC-V. And I'm sure I will give you some exciting freebies. Anyone?
Don't be shy.
Don't be shy.
We have someone over there.
Should we go from?
Hi there. So my question is, how does RISC-V stack up in power consumption versus essentially computing power compared to ARM, or how it will stack up when it's ready for consumer use?
Oh, that's a chicken and egg question, And it's not going to be honest. Next year, we're still trying to compete in certain segment. It's not going to be perfect. Well, now we in our top KPI in the whole chipset-wise is for sorting out performance first before we talk about the PPA on the power consumption. So that's the first step, and then we will think about how do we solve the consumption. So last year focus more on performance.
Okay, thank you.
Thank you.
So you're talking about performance. So what's and I saw on that that nice slide for the next year roadmap. Where's gaming on this list? Like I want a game on a RISC-V system.
Whoa, whoa. We should talk about it. At least I will get.
I have a Framework 16. I'll put a board in if you let me game on it.
Okay. Okay, and there's not just Framework 16, right? We have a game console coming.
Ooh.
Well, enough we can talk about it.
I think the question is, how old of a game do you want to play? I know
It certainly can run Doom. We know it can run Doom. That's
Yeah.
That's
Well, we
important.
can ask Mark, back in the old day, Ubuntu, what games plays? Then we'll do it. We will do that first. And in fact, I might work with Brad Smith Wukong, get onto our framework console. All right? Good luck to me. And I might have to convince NVIDIA again, give me a GPU that run on frameworks laptop with a RISC-V CPU. A lot of convincing to do, right, Mark? You know?
Okay.
Thank you.
One last very quick question. The rest just follow them to the booth. They're here all the time. At the risk of clearing the room, please don't. The others are good as well. So one last one.
Can you describe the turnaround from your design to getting a chip on your hand?
You mean the turnaround time?
Yeah. And the process?
My style is really like military style, you know, startup, dictatorship. My guys are killing me, and you're killing me. Always, I do a motherboard, 3 months to EVT, and then 6 months to DV to mass production. That's our game. If anything beyond that, and then it's my job not doing good enough. So for the chipset, it's harder. Chipset usually they need once a year. You can see all these chipsets, the 64 core, they did it once. Last year they do a refresh, do it again, fix all the problem. And for the 8 core, this first time they ever done, they took them 3 years. But the refresh one is very quick. And for the 4 core, it's the 8 core half them, so it's simpler, so it's quicker. But for the 12 core, it's another vendor that they completely new. So it takes probably chipset is at least minimum 18 months. So most of the chipset startup is just have a chance, have enough funding to do 2 chips. If they can't scale, then they die. So hopefully I answer all you guys' questions. And remember, 3 of you. So, and come around my booth and collect the freebies. Thank you. Thank you. Back to Christian.
Thank you.
Thank you, Gordan. Thank you, enough.